I was wanting to do a video on vectors and 3D geometry for some time, but I was keeping a bit busy. So anyway, in this video I'll be doing questions from 2019 papers. I have taken 6 questions over here. One, two, all of them being on vectors and 3D geometry. So vectors and 3D geometry like is almost always connected because we use the equation of planes and lines, straight lines using vectors. So they are almost connected to each other. Like if we look at this question 6, this is an equation using vectors, but what is this? This one is a straight line and this one is a plane. So vectors and 3D geometry are almost connected, like very closely to each other. So let us look at the first problem first. So in this one, we are given that the position vectors of 2 points A and B be A plus B plus C and A minus 2B plus 3C respectively. If the points P and Q divide AB in the ratio 1:3 internally and externally respectively, then 3 mod of AB vector is equal to which one of these? So you don't really need to indulge yourself in all this vector algebra to solve this problem. Like you will be thinking that maybe I should find out the vector of point P and then point Q in terms of A, B and C, and then try to calculate the length of AB and calculate the length of PQ and then do comparison. It will take more than 10 minutes, I'm telling you, if you start going that way. But what we can do is just do it geometrically. It's a really easy problem if you think about it. So let us assume this is the straight line AB. Don't mind my drawing. This is a straight line, just believe me on that. So AB is a straight line and point P is dividing AB in the ratio of 1:3 internally. So let us assume point P is somewhere here. So what we are given is this AP is 1 and BP is 3. So if the whole length AB is x, can we find out what is the length AP and BP? Of course, if this one whole length is 4 and x equals to 4, what is this? 1 unit will be equal to x by 4. And this one will be 3x by 4, that's it. Because P divides AB in the ratio 1:3, so if this whole length is equal to 4 units, this one should be equal to 1 unit and this one should be equal to 3 units. Now we are saying let us assume AB is of length x, then AP has to be x by 4 and BP has to be 3x by 4, that's it. Now let us look at point Q. Point Q is dividing AB in the ratio 1:3 externally. So if this is A, this is B, point Q is somewhere around here. Externally, that means it doesn't lie between A and B, it lies outside of A and B. And internally means P lies within AB, it doesn't lie outside of AB. So in here, this part is 1, okay, and this part is 3. So do not make the mistake of using this part as 1 as this part as 3, because Q is dividing AB in the ratio. So it has to be AQ is to BQ. So this whole length has to be 3, not just this part. This part, if you take it as 3 and you go on and solve this problem, you will be making a mistake and you will lose your marks in the exam. So this is 1 and this is 3. Now we know this length is x. We have assumed AB as x. So this will be how many parts? 2 parts. X by. So 2 parts equals to x. Then 1 part will be equal to what? X by 2. Right? So this is x by 2, whole of this will be 3x by 2. So x by 2 is to 3x by 2 is 1 is to 3. So our assumption is correct. Now what do we need to calculate? 3 times AB mod is equal to how many times PQ mod? Let us try to calculate the length of PQ. PQ. PQ is what? AQ plus AP. AP plus AQ. I have done this one in a separate diagram just to make it easy for you, but you can do this. So that's easy for you to understand what's going on. P is dividing AB in the ratio 1 is to 3 internally, and Q is dividing AB in the ratio 1 is to 3 externally. So length PQ is equals to AP plus AQ. AP is how much? AP I believe is x by 4, and AQ is how much? X by 2. You can write this as well. So this is just kind of notation. When I write PQ without the vector head, it means the length anyway. So x by 4 plus x by 2, take the LCM of 4. This is 1. This will be multiplied with 2. So 3x by 4. 3 by 4 of x. And what is x? X is the length AB, which we have assumed in this problem. So I can just write 3 by 4 AB mod here. Okay, which is equal to PQ. So what will be 3AB? That's easy, right? Just take 4 over there. You get this 4PQ. So that's easy and simple. Now let us look at problem number 2. So problem number 2 is a bit tricky. You will have to you'll have to think through this one. This is not as straightforward as this problem number 1. This problem number 2 is a bit tough, I would say. Since these are, okay, so what is the problem? A, B and C are three non-collinear points, and this vector is a point in the plane of A, B and C. Then what is K? We have to find the value of K. Okay, some people will just do, oh, this is 2, this is 3, and this some will be 5. K should be like -5. Go with -5. No, that's not correct. Let us do it properly. So I have three non-collinear points. I know the equation of the plane would be r minus a dot b minus a cross c minus a is equal to 0. This is the equation of plane which is passing through these three non-collinear points. So this is a very standard result. If you don't know, you can have a look at the book and you will find that this is a standard result. So how do you arrive at the equation of plane in such a manner? How do you get this as the equation of the plane for 3 points which are non-collinear? So A, B and C are three non-collinear points and they are lying on a plane. So you know that vector B minus A and C minus A will lie on that plane, right? If this is a plane, they will lie on it. They're lying on this plane. So when you take the cross product of these two vectors, it will be normal to the plane, right? So it will be normal to the plane. So if you have any vector r for the plane, you can do the cross product with the normal. R minus a will give you the r minus a will be lying on this plane, just like b minus a and c minus a are the vectors which are lying on this plane. r minus a will lie on this plane, okay, and r minus a value, when you take a cross product with the normal, since the angle between them is 90 degrees, the dot product will be 0. So this is the result that you will have to use while solving this problem, and that's why this problem is a bit tricky. Now R is a general point which signifies the plane, and this point is lying on the plane, so you can substitute it over here. You will get what? Ka plus 2b plus 3c minus a dot with b minus a cross c minus a is equal to 0, 0. So this is not 0 vector here because this is a dot product. Dot product is a scalar quantity, so it will only be 0, not 0 vector. Okay, so what is this? K minus 1a dot with b minus a cross c minus a plus 2b dot b minus a cross c minus a plus 3c dot b minus a cross c minus a is equal to 0. Okay, in this original equation, if you substitute a here, so a minus a will be 0, 0 dot this vector will be 0, so it satisfies. If you put b over here, so this will be b minus a dot b minus a cross c minus a. B minus a vector cross product with the c minus a vector. So this will be perpendicular to b minus a as well as c minus a. So if you take b minus a dot with a dot with a vector which is perpendicular to it, will you will be giving 0. When you put c over here, c minus a dot with b minus a cross c minus a, again this will be another vector which is perpendicular to c minus a. So if I take a dot product of c minus a with a vector which is perpendicular to it, I will get 0 again. So we know that this equation is correct as it satisfies all the 3 points a, b and c which are lying on this plane. Okay, now what do I have here? I have a dot b minus a cross c minus a. I don't know what is the value of this vector. What this vector is. This is the normal. I don't know what will be the dot product with a. I don't know. I don't know the value of the dot product of b with this normal vector or the dot product of c with this normal vector, but I do know the dot product of b minus vector a with this will be 0 because this is b minus a will be perpendicular to this vector. Similarly, c minus a is perpendicular to this vector. So I can change these to b minus a plus a whole dot product. I will do the similar operation here, c minus a plus a and dot product. Why am I doing this? Because c minus a dot product with b minus a cross c minus a will be 0. So this whole term will be reduced to 0, and similarly b minus a dot product of b minus a cross c minus a, it will also be 0. So in the end I will be left with this k minus 1 plus 2a. So plus 2 plus 3 a dot b minus a cross c minus a is equal to 0. So this is what k plus 4. K plus 4 A dot B minus A cross C minus A is equal to 0. Now we don't know what's the value of this A dot B minus A cross C minus A. It may not be 0. It may not be 0. It might be 0, it might not be 0. But k plus 4 has to be 0, right? K plus 4 is 0 is a solution of this equation. So k plus 4 is 0. That means k is equals to minus 4. That's it. The next problem. So this is a bit different. So in this one, a vector 3j plus 4k is the sum of two vectors a1 and a2, and vector a1 is parallel to vector b, which is equals to I plus j, and vector a2 is perpendicular to b, then a1 is what? So this is also a kind of a tricky problem. Vector a is given as what? Sum of a1 plus a2, and a1 is given as parallel to b, and a2 is given as perpendicular to b. Now we have to find a1. Okay, so a is given to us, a1 is not given, a2 is not given, b is given to us. A1 is parallel to b, so a1 is just a scalar multiple lambda multiplied with vector b. That's easy, right? And b vector is given to us as I plus j, so this will be what? Lambda I plus lambda j. This will be my vector a1. Now that I have vector a1, I also have vector a. I can calculate vector a2. A2 will be what? A minus a1. So when you do this vector algebra, is almost the same as simple linear algebra. Almost the same as that. Only that a bit of geometry is involved in here, and you have to imagine kind of a 3D plane, or a line that's in 3 dimensions. Instead of just an xy plane, you have a line which may be in an xyz plane. So that's the only difference. So you just need to imagine a bit. Imagine the 3D spaces instead of just working on 2D spaces, which has been the norm. So that's the only new thing with the vectors and 3D geometry. The z-axis comes into the picture, which was absent before this, but now suddenly it's there. You cannot do anything about it. You just have to get used to it. Okay, so I have done this subtraction of this a1 vector from a. So what I get is minus lambda I plus 3 minus lambda j plus 4k. Now this is my vector what? A2. I have been given that A2 is perpendicular to B. So now when you know that two vectors are perpendicular to each other, their dot product is 0. So A2 dot B is 0. A2 dot B is 0. That means B is what? I plus J. So minus lambda plus 3 minus lambda is 0. 2 lambda is 3. Lambda is 3 by 2. Lambda 3 by 2, that means A1 was what? Lambda B, which was lambda I plus lambda j. So A1 is what? 3 by 2 I plus 3 by 2 j. That's it. This one was an easy problem. Let us look at the fourth problem. This one is a bit tough. The angle between the line of intersection of the two planes and the line this is what? We don't know. This is a tricky problem. So the equation of one line is given in this form, and the equation of second line is given in this form, which is the intersection of two planes. So if this is one plane and this is like another plane extending below like this maybe, so this line which lies on both the planes is given as the intersection of these planes. This is P1 and P2. P1 may be this, P2 may be this. So P1 and P2 are intersecting at straight line, and another line is given, and we are asked to find the angle between the intersection of the two planes. So finding the equation of one line from this is uh, is kind of not tough, but some work is involved. This one is straight away given as the equation of the line. So first we need to find the equation of line from these planes and put it in this form. The second one is given to us straight away, so we need to work on this and find out the equation of the line. So how can you find out the equation of the line from two planes? We know that this line is lying on plane P1, it is also lying on plane P2. So the normal to the first plane is normal to this line, and normal to the second plane is also normal to the line which lies on both the planes. So we know that this line, which is the intersection of P1 and P2, is normal to this vector and is normal to this vector. And these two vectors are what? Normal to these planes, normal vectors of these planes. So if there is a vector v1 and vector v2, and we know that there is another vector v3 which is perpendicular to both of them. So we know that v3 is what? v1 cross v2. So we know that the equation of this line is nothing but cross product of these two. It is the cross product of these two, right? This line is parallel to the cross product of these two vectors. Now if we write v3 as 1 point plus lambda v1 cross v2. v1 and v2 are the normal vectors, and this is the third line. So first we do cross product of these two vectors and we find out this vector, and then we are given the this vector, the line is parallel to this vector. We will have two vectors, we just take the cross dot product and we can find out the angle between the two lines. So that's a straight away CBSE level kind of question, this one. So it's not that tricky, it just needs your time. So if you have studied NCERT books for class 12th, you will know how to do this problem. So, or the other way to solve this problem is put it in the Cartesian form x, y, z, and then from there you can find out the value. Let's try to do it from the Cartesian equation. So this plane is what? 2x plus 2y minus 3z equals to 5. 2x plus 2y minus 3z is equal to 5, and this is 3x plus 3y minus 5z is equal to 3. So multiply this equation with 3 and multiply this equation with 2, and then subtract and find the value of z. What will I get? 6x plus 6y minus 9z is 15. 6x plus 6y minus 10z is 6. Subtract the 2. Okay, so when I multiply this equation with 3, I will get 6x plus 6y minus 9z equals to 15. When I multiply this one with 2, I will get 6x plus 6y minus 10z is equals to 6. Right? I'm doing it correctly. Yeah. Now let us subtract these two. These two will get cancelled. 10z minus 9z is what? Z is equals to 15 minus 6 is 9. So z is 9. When you put z is 9 over here, 2x plus 2y minus 9 times 3 is 37. 27 plus 5 is 32. So x plus y is 32 by 2 is 16. So if x equals to k, y is what? 16 minus k. So the equation of this line can be written as this: 0i plus 16j plus 9k plus lambda 1 minus 1 0, or I minus j and 0, right? So the first line is parallel to this vector, which is I minus j. This is the line 1 is parallel to this line, and line 2 is parallel to 5i plus 5j minus 7k. Okay, now when you look at this line 1 and line 2, if I take the dot product of these two vectors, you will get what? 5 minus 5 plus 0. 5 minus 5 is 0. So the dot product is 0. That means the angle between the two lines is what? Pi by 2. So this is a CBSE level problem, very easy problem. It just takes time. It doesn't need that much of thinking, but it takes a lot of time. So if you are good with the practice, if you have practiced enough NCERT problems, this one should be doable easily. Doesn't need much of your brain. Whereas this question 5, I think this one was a bit tricky. This one was a bit tricky. Okay, so what is this problem? X equals I plus j and y is 3i minus 2k. Then the vector r of magnitude square root of 21 satisfying r cross x is y cross x and r cross y is x cross y is. Okay, x and y are given. Some people will start computing x and y cross product, then y cross x, and then they will see r cross x is given, r cross y is given. Then they will assume r as ai plus bj plus ck. They will have one equation from here, one equation from here. Magnitude of square root 21 is given. So third equation will be a square plus b square plus c square equals 21. They will solve three equations and then they will find out the value. This will take 15 minutes. 15 minutes will be wasted if you try to do that way. If you are quick or fast, maybe 10 minutes, 5 to 10 minutes. But this problem doesn't need 5 minutes to 10 minutes if you do a bit of critical thinking over here. So r cross x is given as y cross x and r cross y is given as x cross y. We know that x cross y and y cross x. So these two, the cross product of these two vectors, are they equal? No, the signs change. X cross y is equals to minus y cross x. So I can write r cross y is equals to minus y cross x. X cross y is written as minus y cross x. And y vector y cross product with vector x is given as r cross x. So I can bring it over here. R cross x plus r cross y is equal to 0. Take r common. So the cross product is 0. Cross product is 0, that means these two vectors are parallel to each other. R and x plus y are parallel to each other. That means r can just be written as lambda which is a scalar quantity, times x plus y. What is x plus y? I plus j plus 3i minus 2k. So x plus y is given as I plus j plus 3i minus 2k. So that is 4i plus j minus 2k. 4i plus j minus 2k. Now, if you look at r, r is nothing but lambda times 4i plus j minus 2k. So we are almost at the end of the problem. Now we only need to find out lambda. But how can we find out lambda? Well, the magnitude of r is given to us as square root of 21. We can find out the value of lambda easily from there. The magnitude of this vector is given as square root of 21. What will be the magnitude from here? You need 4 lambda whole square plus lambda square plus minus 2 lambda square is equal to 21. Right? This is the magnitude of a vector. I have squared it. So 4 plus 4, 4 into 4 is 16. 1 into 1 is 1. Minus 2 into minus 2 is 4. 16 and 1 and 4 is what? 21. So 21 lambda square is 21. That means lambda is equal to 1. Or lambda may be minus 1 as well. Lambda could be minus 1. So the vector r is 4i plus j minus 2k. 4i plus j minus 2k. Or it may be minus 4i minus j plus 2k. But that option is not here. So we will take this one. So this was a tricky problem. You just have to think a bit. Otherwise, you will assume R as AI plus BJ plus CK. From the magnitude, you get one equation which is A square plus B square plus C square is 21. Then you do one cross product here, one cross product here, one cross product here and here. Get two more equations in A, B, and C. Solve three variables, three equations. It will eat up a lot of your time, and it's just a waste if you don't think through. Now this question is another CBSE level problem. It's just straightforward problem. If you have done an NCERT, this should be doable easily. The acute angle between this and this. So what is this? This is a straight line, and what is this guy? This guy is a plane. So and the straight line is parallel to this vector, and this is the normal vector of the plane. So if this is my plane and this is my straight line, he wants to me to calculate the angle theta, acute angle. What I can do is I can find out the angle between the normal vector, which is this one, normal to the plane, and calculate theta 1. I can get theta is equal to 90 minus theta 1. So line is parallel to this vector and normal vector is this. I will just take their dot product to calculate the angle between them. Dot product will be what? 2i plus 3j plus 6k and 10i plus 2j minus 11k. So 10 into 2 is 20. 3 into 2 is 6, 26. 6 into 11 is minus 11. So minus 66. 26 minus 66 minus 40. So you have minus 40 over there. So that means the angle between the normal and the straight line is more than 90 degrees. Straight away you know that. And the square root of this, what is this? 4 and 9, 13. And 36, 49. 49 square root is 7. And 10 and 10, 100. And 404 and 121, 225. 225 square root is 15. You divide both by 5 minus 8 by 7 into 3 is 21. So cos theta, which is the angle between the normal and the straight line, is minus 8 by 21. So you know that this is the kind of situation that we are having right now. This is line, this is the normal, and this angle between them, which is more than 90. That's why cos theta is negative. This is the theta. But we do not want this theta. The theta that is the angle that is asked with us is the angle between the plane and the normal, which is this one. This angle alpha is asked. Well, the angle between normal and plane is 90 degree. This theta is given. So alpha is what? Theta minus pi by 2 or 90 degrees. Theta is given to us, which is cos inverse of minus 8 by 21 minus pi by 2. So I can write this as pi minus cos inverse of 8 by 21 minus pi by 2. Pi minus pi by 2 is pi by 2. Pi by 2 minus cos inverse of 8 by 21. Now this is I think sine inverse of 8 by 21. Yeah, that's it, we're done. So these are the six problems. This problem is straight away easy CBSC problem. This problem is a bit tricky. This is again CBSE level problem. This one is also kind of CBSE level. This one is a bit tricky. This one is very straightforward. Doesn't need much thinking. So out of the six problems in the paper, four were very easy and two were a bit tricky. So if you are if you have practiced the CBSE well, you should do 66% problems without any issues. Okay, if you have any problems, please write in the comment box below. Thanks.